Hello, everyone. Today, I'm thrilled to introduce our project, the EcoAI Conservation Portal. As we face the rapid decline of biodiversity and endangered species, timely and accurate conservation strategies are crucial. Traditional methods can be slow and resource-intensive, leading to inefficiencies in protecting our vital species. Our portal combines machine learning, geospatial analysis, and data-driven optimization to create an integrated solution for detecting endangered species and generating conservation strategies. When you enter the portal, you'll see a Start Exploring button. Clicking this takes you to a drop-down menu to select a continent. For example, if you choose Asia and hit Search, you'll see a list of the most endangered species in that region, including their common and scientific names, along with recommended conservation strategies. Selecting Europe highlights critically endangered species with visual aids like graphs that pinpoint the most threatened plants. This feature empowers users to engage in conservation efforts based on their geographic area. Currently, our data focuses on continents due to limited datasets for countries and local areas, but we plan to incorporate more localized data in future updates. Our website features several sections on vital conservation topics. Protecting plant species. Here, we spotlight initiatives aimed at conserving endangered plant species critical for biodiversity and ecosystem health. We identify at-risk plants through research, restore populations with targeted programs, and collaborate with local communities to promote sustainable practices. Promoting ecological restoration. This section outlines our efforts to revive degraded ecosystems. We emphasize restoring biodiversity, protecting natural environments, and partnering with local communities to enhance ecosystem health, crucial for reversing environmental damage and preserving wildlife habitats. Health and biosecurity. Protecting plants from pests and diseases is essential for maintaining ecosystem stability. We develop pest management strategies, advance research for early disease detection, and set biosecurity guidelines to prevent invasive species. We provide powerful insights through data visualizations, including heat maps that identify regions needing urgent conservation efforts. Our pre-processing of the IUCN dataset revealed that at-risk plant species are heavily concentrated in tropical areas, making them priority zones for conservation. These visual tools help us understand where our actions can have the most significant impact. In our Addressing Global Challenges in Plant Conservation section, we tackle critical issues threatening plant species worldwide. Key challenges include climate change. We assess its impact on plant life and work towards mitigation strategies. Habitat loss. We develop strategies to protect ecosystems affected by urban expansion and agriculture. Invasive species. Our focus includes controlling species that disrupt local plant life. Pollinator decline. Protecting essential pollinators crucial for plant reproduction. Before I wrap up, here are a few endangered species we must protect: the tiger-tailed spruce, Tora momi, ohohi, and West Indies juniper. Now, let's move on to the data pre-processing stage, which was essential for developing this website and the content we've shared. To gain valuable insights from our data, we began by pre-processing the dataset. First, we loaded the IUCN Endangered Species dataset, which includes extensive information on various species worldwide. We filtered the data to specifically identify endangered and vulnerable species, and as shown here in the graph, we can visually see the breakdown of these species. To enhance clarity, we then renamed certain columns to make the information more understandable. Next, we created a copy of the data frame to ensure we could work with a stable dataset version, preserving the original data. After this, we performed a crucial step, merging our dataset with another dataset using the species ID as a unique identifier. This allowed us to enrich our data by bringing in additional attributes such as family classification and scientific names. Here, you can see a display of our final data frame, which includes important fields like species ID, common name, scientific name, and the family to which each species belongs. Printing the final data frame showcases our organized data, ready for analysis and actionable insights. This comprehensive dataset enables us to provide a clear view of endangered species and helps drive effective conservation strategies. Continuing with our data pre-processing, we focused on extracting only the relevant columns needed for our analysis. We specifically selected columns such as species ID and other essential attributes, and removed any columns that were not directly relevant to our project. This allowed us to streamline the data, making it easier to work with and analyze. To ensure consistency, we converted the species ID column to a string format, which facilitates easier data manipulation in later steps. Now, we can see a summary of our clean dataset, including the status counts across different conservation categories. This includes species categorized as least concern, vulnerable, data deficient, and even extinct, along with their respective counts. By quantifying these categories, we gain a clearer understanding of the distribution and urgency of conservation needs. Here you can see a list of the top endangered species specific to Asia. For each species, we provide the common name and current conservation status. This includes categories such as endangered. By displaying details, users can gain insight into which species are most at risk in this region and understand the urgency for conservation efforts.